Hello and welcome to this video series. My name is Jonathan Ross. I'm a professor at Western Kentucky University and I teach accounting in the business school. I've been a professor for about 10 years now. I was previously on the faculty at Binghamton University in Binghamton, New York, and I graduated in 2013 with my PhD in accounting from the University of Kentucky. So in this video series, I'm going to teach you all how to use Matlab. I'm going to assume no background knowledge at all. We're going to start from the ground up, teach you very basic things first, and work our way to more difficult things. And the reason I wanted to do this video series, I've always wanted to instruct PhD level students in how to use Matlab to do accounting research or finance research if you're a finance PhD student. Or even if you're not an accounting or finance PhD student, you're someone interested in doing research, archival research where you have data and you want to use Matlab to do it. In this video series, the various things I teach you will be, in the context of accounting or finance related research. But if you're not in accounting or finance, the things that I teach you will be applicable to any sort of data analysis you might want to do. So let's get started. I guess first off, how do you get Matlab? So if we go here and just type in Matlab, there are several licenses that you can purchase, several types of licenses. So the one I'm looking for is to show you is the home license. Maybe I didn't search for it correctly. Matlab Home Edition. So this is the cheapest way to get Matlab for life. It's a lifetime license. You don't have to keep paying for it. It's $150 and you get, it's called the Matlab Home Edition, and it comes with, if you look here, it comes with the base Matlab, as you can see, and then these other things, these other toolboxes, you can buy these a la carte. Each one is $45. So in terms of what I use in Matlab, I obviously have everything in Matlab because I don't have the home version. I'm a faculty member and I have all of it with my school subscription. But if you don't have a school subscription, then you can come in here and buy the home version, get the base Matlab, and then the functions that I usually use. You don't need all these toolboxes. You need, for archival research, data analytics type stuff, you probably need this toolbox here, maybe the financial toolbox, and let's see, all these other toolboxes I don't really use. Probably this one right here, Statistics and Machine Learning Toolbox. Those three toolboxes plus the base level of Matlab, and you'll have access to most of the functions that I use on a regular basis to do research and that you would use. So this is how you get Matlab. Obviously, if your institution, if you are a student at an institution or a faculty member for that matter at a university, and your university has a license for Matlab, then you can use your university credentials to log in and you can download and install Matlab. But if you don't have that, you can still get Matlab for a pretty cheap price, which is a good thing. Most softwares that you use for data are really expensive. Not all of them. R and Python are, I think, free. Matlab's not free. But Matlab, R and Python are good alternatives to Matlab. but I'm going to show you all Matlab. I'm biased towards it because I've been using it for so long. I think it's wonderful. You can do anything. So let's open Matlab here. Now I have all of Matlab installed because, like I said earlier, my school subscription. So I was working on a script file, a code here earlier. Let's close that. So when you open Matlab, you'll just have your command window here, and you'll have your workspace over here. So we're just going to start from the very beginning. Your command window is where you type commands. Each command you type, you need to follow it by a semicolon before you hit enter to run the command in the command window. If you do that, then the result of your command will go over here in the workspace. If you don't do that, the result of your command will go in the command window and in the workspace. And if it's a long command, or if it produces a large result, then the command window will just keep filling up. So you're going to want to remember to type a semicolon after each line of code that you type. If you don't do it, it doesn't mean there's an error. It'll still run your line of code, but it's a best practice. So semicolon after every line of code. Now what we're going to do is I'm just going to show you how to do some simple commands. And we're just going to run those from the command window. But in general, you don't use the command window to run commands. In general, you make a script. It's called a matlab.m file. It has a .m extension, just like a Word file has a .doc extension and so forth. MATLAB script files have a .m extension, and you make a MATLAB script file to type all your code in. So to do that, you hit plus up here, script. You type all your code here. And then you highlight the lines of code that you want to run. Once those are highlighted, you push F9 on the keyboard, or you can click this right here. Or you can push F5, it looks like, as well. But I usually just highlight the lines of code I want to run and push F9, and it runs all those lines of code that I highlighted, and the results go in the workspace. So that's the way you usually want to run your code. But we're not going to do that to start with. We're just going to do it the old-fashioned rudimentary way, where we type line by line into the command window, which I don't recommend doing this usually. You make a script file, you type all your lines in the script file, you save your script file. You can't save your command window when you exit, so that's another reason to use your script file, so that you can save all the code that you've typed. All right, so MATLAB is short for Matrix Laboratory. MATLAB stands for Matrix Laboratory. And it views things as a matrix always. So you're going to be just think about with your data, think about a matrix. It has rows and it has columns. MATLAB has a ton of different functions that I've already pre-configured. You just have to know what those functions do. There is extensive online documentation and help. There's a help forum for MATLAB. So certain functions, if you don't know what they do, you can just go to MATLAB. Like for example, let's take the MATLAB function, I don't know. How about just the MATLAB function mean? You just type in the function, type MATLAB, and then click here, and here's the syntax of the function. Here's the description of the function, and it gives you a bunch of examples of how the function can be used. Basically, the things I'm going to show you in this video. You can teach yourself MATLAB because of the extensive documentation. Now, if you have a particular question and you don't know, like for example, how to find the mean of a column, or let's say the mean of values which include nan, MATLAB. So in MATLAB, a missing value is given the value nan. And if you're wanting to find the mean of a bunch of values, but a few of them are nan or missing, how do you find the mean of all those? So you just type this question into Google, and there's a function called nan mean. NaN mean of x returns the mean of the elements of x computed after removing the NaN values. Perfect, just what we want. Now, if there isn't an actual function which answers your question, then you can just look in the forum. So down here at Matlab, if you look up here at Matlab Central-Answers, you have extensive forum, and pretty much every question you could ask regarding data, no matter how particular your context is, has been answered on the forum. So Matlab has an extensive forum and online documentation. So this right here shows how to get rid of the NaNs before calculating the mean with the normal mean function in Matlab. But it turns out there is a NaN mean function now, so you don't even have to do it this way. But this is how you would do it. And then you can look at the answers that were accepted with a check mark, and those are the answers that actually worked in response to the question that was prompted. This answer worked. It gave the person who asked the question the answer that they were desiring, and so forth and so on. All right, so let's start teaching. So in Matlab, you can give the most simple element is a double array. Often these are called variables in other software programs, but in Matlab we call them arrays. I frequently use the two terms variable and array interchangeably. So sometimes I'll say variable, sometimes I'll say array. But technically they're called arrays, and a double array is the simplest one. You can give an array any name you want using lowercase or uppercase alphanumeric characters. You can even use underscore in the name of a variable. But those are the only characters on the keyboard you can use in naming an array or variable. You can't use other special characters in the name of your variable. So let's give it a variable a name. We're going to call this double array little x. We're going to say little x equals, now you don't have to put a space between that. You can just go like this. You don't have to have a space there. But I put the space just for easier to follow along visually when you're watching the video. So we're going to let x equal a little matrix that's going to have 2 rows and 3 columns. So x is going to be a double array. And we're just going to, let's say the first 2 rows, or let's say the first, it's going to have 2 rows and 3 columns. Let's say the first column we want to be 1. Should we do it by rows or columns? Let's do it by rows. So the first row is going to be 1, 2, 3. The second row is 4, 5, 6. And the third row is 7, 8, 9. Let's see if this will work. Type that semicolon afterwards. Otherwise, when you hit enter to run this line of code, the result will show up down in the command window. But if you type that semicolon, the result just shows up here in the workspace. Here, I'll show you what it does if you just do this without typing the semicolon. The result of what you typed will show up down here in the command window and over here in the workspace. So there's our matrix X. It actually has 3 rows and 3 columns. So the first row is 1, 2, 3, second row 4, 5, 6, third row 7, 8, 9. And here's the syntax, you see. So the left bracket means start the matrix or start the double array. Right bracket means end the double array. X is a double array. And you use commas to separate columns, and you use semicolon to separate rows. So we're in row 1. There's a 1 in the first column, then a comma, a 2 in the second column, then a comma, a 3 in the third column. Then we move to row 2, semicolon. There's a 4 in the first column, a 5 in the second column, a 6 in the third column, and so forth. Now that we have X here, what if we wanted the the element of x that is in the second row, third column. So x, now we do parentheses 2 comma 6. So when you use this syntax here, this gets the element in the second row, third column. So when you have your double array here and you have your parentheses, your left parentheses and your right parentheses, then whatever's inside there, you're picking out elements of x. And the first position before the comma is reserved for the row position, and the second argument here is reserved for the column position. Whoops, I didn't mean to do 2 comma 6. 2 comma 3. So second row, third column, and that should give the number 6. Right? Because that's the second row, third column of x. Notice when you just put this here and you don't set anything equal to this, then this just gets assigned the default double array A and S for answer. But then notice the default double array A and S gets assigned something else if we do this. So we want the third row, second column element of x. That's the 8 right here. But we're not setting this equal to anything. So by default, it's set equal to A and S. A and S is the default. If you don't name a variable, if you don't name an array, it's set equal to it. The name of the array is given by default A and S, ants or answer. So everything in Matlab has to be given a name, has to be assigned a name. And if you don't assign it a name, like right here, and the way you assign it a name is you use 1 equals sign. So if instead I want the 6 to be given, I'll let A equal the 6. So A equals the second row, third column of x, and B equals the third row, second column of x. So A is the 6 and B is the 8. Now I can let C equal A plus B. And of course that'll be 6 plus 8, which will be 14. See how this works? Or if I didn't want to do those extra steps, I could just say let C equal x row 2 column 3 plus x row 3 column 2, and you still get your 14. So hopefully this is enabling you to see what's going on here in MATLAB syntax-wise. Now, if you want to clear the command window from all the commands you've typed, it gets all full with commands. You can see all the commands up here. Now, you don't often want to clear it. I mean, sometimes you want to clear it, sometimes you don't. You might want to, because if you clear it, then previous commands that you may want to go and copy and paste later, you can't get to them anymore because they're cleared. But clearing the command window is easily accomplished by typing CLC and then hitting enter. That clears the command window completely. What if you want to clear the variables that you've created in the workspace? If you want to clear all the variables, clear vars. If you want to clear all of the variables except certain variables, so clear vars except, let's clear all of them except for B and C. So that'll clear everything and only leave B and C. Now, if we want to clear just B or C, or if we want to clear one particular variable, we just do clear B like that, for example. And that clears B and C is left. And then finally clear C. So you see how clear vars works, you see how clear vars except works, and you see how just plain old clear works. All right. We cleared the command window, cleared the workspace. Let's keep going. So let's assign X again. I'll assign it something different here. I'm just randomly picking numbers here. We'll add a fourth row. So there's our matrix X, 4 rows, 3 columns. Let's suppose we want to multiply every element of X by the number 2, for example. and we'll let the output of that, we'll name the output of that y or something. So y equals 2 times x. Every element of x is multiplied by 2. What if we want to subtract 2? Subtract x. Subtract every element of x from 2. Y equals 2 minus x. I try to put a space in between there. That way you can see what I'm typing, but you don't have to type that space. You can just go like that. 2 minus x. So now y, which is currently this, is reassigned this, 2 minus x. So 2 minus 1 is 1. 2 minus 2 is 0. 2 minus 4 is negative 2. Every element of x is subtracted from 2. And the result is output as y. Oh, actually, I didn't set y equals. I just typed 2 minus x here. Y equals 2 minus x. So there's y. There's y. Again, if you do not assign this to anything, here we assigned it to y, then it's given a name a and s by default. Answer is the name given to all arrays that are not designated a name. What if I want to come back up here to x again? Let's say I want to multiply let's say I want to multiply just the first column of x by 2. But the other 2 columns don't multiply by 2. So y equals 2 times x, all rows, column 1. And that'll just be a column vector where it's just this first column here multiplied by 2, and that's assigned to y. But I want y to be that in the first column, and the rest of y to be the other 2 columns of x. So the rest of y, so that's the first column of y, 2 times the first column of x. And then the rest of y, the second and third columns of y, so I have to put this comma here because we're going to the next column. The second column and third column of, we can either do it this way. The second column of y could be x, all rows, column 2, and then the third column of y could be x, all rows, comma 3. You could do it that way, or you could just do it this way. The second and third columns of y will be all rows, columns 2 through 3 of x. You can do it that way as well. So the colon means all. Again, this is the rows position to the left of the comma. This is the columns position. And a 2 colon 3 means 2 through 3. So this right here will produce a matrix that looks just like x, except the first column will be 2 times this column. You see, y equals basically what x was. It's x in the second and third column, but it's in the first column we have 2 times the previous first column of x. So you can do that. What else? What if you want to multiply the third row of x by 3? So y equals, now x, row 3, all columns. So 3 times that. So what if I want a new matrix? I'm going to call it y. It's going to be what x was before, except the third row of x the third row of this new matrix Y is going to be the third row of X multiplied by 3. But the first, second, and fourth rows of Y will be the first, second, and fourth rows of X. So it's just going to be, Y is just going to be X, but the third row will be 3 times these numbers here in the third row. This will be the third row of Y. In the first row of Y, we'll have the first row of X. Actually, in the first 2 rows of Y, we'll have the first... Oh, whoops, sorry. In the first 2 rows of Y, we'll have the first 2 rows of X, all columns. Then we have to type this to go to the next row. Then the third row of Y will be that. And then the fourth row of Y will be the fourth row of X. All columns. And you can check to see that this is it's just X up here, except that third row is 3 times. This third row is 3 times. So you can use this video, you can pause the video, you can see how this syntax is working. Just doing matrix operations at this point on this using double arrays. If you want to open an actual variable and look at it over here, you can double click on it and it opens the variable. So you can see it. You can see it says a 4x3 double array. You might say, well, I lost my so your script, if you have a script file, if we go back to home here, if we create a script file, then your script will always be here, your command window will be down here, and your variables will be up, you can put, they'll be up here. Your script will be over here, it looks like. Your variables are over here, and you can move those. You can move that over here, I believe. Variables over here and script over here. You can detach this and move this all the way over here. I have a second monitor over here. I moved it off the screen. You can put it over there on your second monitor if you want to. I do that a lot. But most people just have one monitor. Now let me show you how to do things in the script file. So in a script file, you're usually going to want to do your code in the script file. You can run multiple lines of code. You see what I was doing earlier was I was just running one line at a time in the command window. That's cumbersome. So in our script file, first thing I do in a script file is I make comments to myself what this script file is. So when you type a %sign in a script file, Matlab knows everything after that is just going to be not actual code, but just comments. And the color it gives the font is green by default, so you know that's just comments. So we'll say something like, I like to do this. This vertical line right here just means if you were to print this script file, anything to the right of this vertical line wouldn't show up on the output. But we're not going to print the script file. Let me close this. We're never going to print the script file, so you can type past this vertical line if you want to, although I'm in the habit of not. So this is an example that I am using to illustrate the basics of Matlab. I like to do something like that. At the very top of the script file, I give it a description of what's going to happen in this whole script file of code. Get out of here, Norton. All right. So we already have our matrix X created over here. It's our 4x3. Well, let's say we wanted to, and we have Y over here as well, which is X, but there's the third row is different there. What if we wanted to multiply X times Y? So we'll let Z equal X times Y. That's matrix multiplication. And we'll see if it'll let us do that. Remember, with matrix multiplication, the order matters. right? X times Y is not equal to Y times X when you're doing matrix multiplication. In other words, when you do X times Y, the number of columns of X, which is the second thing here, 3, has to equal the number of rows of Y, which here is 4. So since 3 doesn't equal 4, this is gonna give an error. I'm gonna put my semicolon, type a little comment to myself of what this line of code is doing. Should produce an error. So when you highlight this line of code and you push F9, it'll run this down in the command window. And then if you hear a noise and you get any words underneath what you just run, that means there's an error. It couldn't run what you wanted to run. And it says incorrect dimensions. Check that the number of columns in the first matrix, 3, matches the number of rows in the second matrix, 4, and it doesn't, so it's not going to work. And you can use dot and then an asterisk for element-wise multiplication. So this just tries to do the normal multiplication, matrix multiplication. But if I use dot in this, it would work. That's element-wise multiplication, where it takes the first row, first column of X multiplied by the first row, first column of Y. The first row, second column of X multiplied by the the first row, second column of X multiplied by the first row, second column of Y, and so forth. So this will work if I do this. That's element-wise multiplication. Notice, for example, this should be the first row, third column of X multiplied by the first row, third column of Y. 4 times 4, which is 16. Usually, though, you're not wanting to do element-wise multiplication. You're usually wanting to do regular multiplication. And so the only way for us to do X times Y is the number of columns of X has to equal the number of rows of Y. So instead of doing X times Y, we could do X transpose times Y. Right? X transpose. First, let's go set A equal to X transpose and see what. This is the symbol for transpose. Syntax for transpose. So the transpose of a matrix just takes the rows of the matrix and makes them the columns, or vice versa. Let's run this. F9. So X was 4 by 3. A should be 3 by 4. So here's X. The first row of X should become the first column of A. So 1, 2, 4 should be the first column of A. The second row of X becomes the second column of A, and so forth. So A is the transpose of X. And now we can multiply A by Y, or X transpose by Y. Now we don't have to have this intermediate step here. We don't even have to have this. We can just do Z times, or Z equals X transpose times Y, and that'll work. And here's our Z. A 3 by 4, that's the transpose of X, multiplied by a 4 by 3 yields a 3 by 3. So that's how you do matrix multiplication in Matlab. How often do I do matrix multiplication when doing archival data work in accounting or finance? Very infrequently. Not very often, but in case you want to do it, that's how you do it. Let's try to teach some other functions. We can compute means. So the mean, let's compute the mean of X. That's the mean of every element of X. So we'll let M equal mean of X. So this computes mean of every element of X. I'm sorry, this computes the mean of each column of X. That's how the mean function works. If you apply a mean to a matrix, the output will be, so if the matrix is, how many ever columns the matrix has, that's how many rows the output will be of your mean vector. So it'll compute the mean of this column, the mean of this column, and the mean of this column, and it'll output those three means in a 1x3 row vector. So you can see M here. That was the mean of the first column of X. So if we compute the mean of these numbers, you should get 26.75. This is the mean of the second column of X. So we can go back here. We have X up here. And then this is the mean of the third column of X. So that's how you do that. If you only want M to be the mean of the first column of X, then all rows column 1 like that. Then M will just be one number. It'll just be the 26.75. But if you do mean all of X, it computes the mean. Now, obviously, if you want the mean of each row of X, then all you have to do is take the mean of X transpose. Because the mean function always acts on the columns. So if you want the mean of each row of X, find the mean of X transpose. And there are the means of each of the 4 rows of X. The mean of row 1, the mean of row 2, the mean of row 3, the mean of row 4, so forth. Median, same thing. But the function is median instead of mean. If you want the median of each row of X, you would do that. There are the medians of each of the 4 rows of X. If you want the mean of every, let's say the mean of every value of every element of X, how many elements does X have? 12? It's a 4x3. If you want the mean of all 12 values, then you can do mean of like that, I believe. No, that still gives the same thing. I'm trying to remember how to do that. Well, one way you could do it is you can first find the mean of X. That gives the mean of each column of X. And then find the mean of those means. No, that's not necessarily the mean of each value, is it? I think you can do it this way. Just like that. Because I think this notation just puts all the values of X in one long column vector or one long row vector. Let's actually see what that does. Let's copy this. Let's paste this down here. And let's run that. See, that puts all the values of X in one long column vector, and then you can just compute the mean of that. And that's the mean of all the elements of X. So you have to use that notation. So the mean of every element, if you take all the elements of X, all 12 of them, and compute the mean of all 12 of those numbers, that's the mean of all of them. Notice that's not the same thing. It's taking the mean of each column of X and then taking the mean of those column means. You're not going to get the same thing. You're not going to get the 20.8750. Actually, you do get the same thing. So I guess either way you can do that. I had a brain fart there. Yeah, because you're computing the mean on the same 12 numbers. It's just, you can compute the mean of 4 sets of, or 3 sets of 4 of them first, and then compute the mean of those 3 numbers, or you can just compute the mean of all 12 of them. Either way, you're still going to get 20.8750. So that's mean and median. Standard deviation, same way, same thing. If you want to compute the standard deviation of X, the function is std. So we'll call this SD instead of M. So that's the standard deviation of each column of X when you do it this way. Right here. Standard deviation of each column. If you want the variance of each column, you can either take the standard deviation and square it. And to square it, you just do this. Actually, it does not work. All right, so here you're trying to square a 1x3 vector. But what you want to do is you want to square each element of that 1x3 vector. So you want to do it element-wise. So anytime you want to do an operation element-wise, type a period before the operation. then it'll do it element-wise. So SD now equals the square of the standard deviation of each column of X. So there's the variance of column 1, there's the variance of column 2, there's the variance of column 3. Or if you don't want to do it that way, you can just compute the variance of X, which is VAR. The function is VAR. So I can't assign this VAR. In other words, you cannot assign a variable the name of a function. There are certain functions, there are certain names in Matlab that are reserved for functions. So you can't assign a variable a name of a function. I don't think. I guess you can. I didn't realize that. So that was false. I've already messed up twice here in this video. I'll probably mess up more. So you can do that. I think in previous versions of Matlab, because I've been using this software for a long time, but in previous versions, I don't think you could do that. But they fixed that to where you can assign a variable a name, even if the name you're giving the variable is a function itself. So could I assign a variable the name mean? So mean equals mean of X. What let me do that? I'm guessing so, because I just did it with variance. Yep, it does. Interesting. All right, let's see. How about the MATLAB find function and logical indexing? I think those things are useful, very useful in research. We use those all the time. So first, the find function. So what if I want to find the elements in X? Let's say the elements. Usually when you're using the find function in a research sense, you're just wanting to find whether a certain condition is met in one of the columns of X, one or more than one of the columns of X. So what if I want to find all rows? So with find, it's going to give you the row numbers. Which row numbers of X will satisfy the condition? Like which of these numbers here are greater than 5? Obviously, it's going to be row numbers 3 and 4. We can see that visually. But if we have a, 2 million rows, you can't just visually figure that out. But which of these numbers are greater than 5? So you would use the find function. You would say find 5 less than X all rows column 1. And that'll give the row numbers in column 1 of X, which are greater than 5. It gives the row numbers. And we'll call this. It gives the row numbers. So rows 3 and 4 of X are greater than 5. If you want the actual numbers themselves, well then you have to I'll call them values now. Then you have to, so this will output the 3 and the 4 rows 3 and 4. And then you just have to put that, just say X, those rows, 3 and 4, right? That resulted in 3 and 4. So those rows, column 1, will spit out the values. 56 and 45. See how that works? So it's X, and then, whoops, these rows, column 1. What if you want the rows of X, or let's not say the rows, but the values in the first column of X, or let's say the values in the second column of X that are greater than 13 and less than, greater than 13 or less than or equal to negative 23. So it'd be this and this, right? So the values in the second column of X that are greater than 13 and less than, or not and. There aren't any values that are both greater than 13 and less than negative 23. But the values in the second column of x that are greater than 13 or less than or equal to negative 23. So we're finding, so there's two conditions here in our find. There's two conditions. We had find where 13 is less than x all rows column 2, or, and in Matlab an or, you don't type the word or, you type a vertical line means or, and 1 ampersand means and. This means and this means or. So find, these will be the rows in x. Well, let's, or that are less than or equal to negative 23. So these will be the rows of x right here that satisfy this condition. They're either greater than 13 or they're less than or equal to negative 23. These will be those rows of x. And so we want those rows of x. So right here, that will be those rows of x, and then comma 1. So it should be, these two numbers right here as the output for values. So if we run this, I picked those rows, but then column 1, but I want to pick column 2, because this reports rows 3 and 4, doesn't it? It's rows 3 and 4 in the second column of x that satisfy this condition. Rows 3 and 4 satisfy this condition. So I had those rows, but then column 1, I picked out those rows, column 1 of x, which picked out 56 and 45, because it picked out rows 3 and 4 of column 1, but I want these. So I need to change this to column 2. -78, -23. So that's how you can use or. If we use and, we could say which rows, what are the values in column 3 of x that are greater than 0 and less than or equal to 36. So it should be these two. We're in column 3. So we're in column 3 here. So greater than 0 and less than or equal to, what did I say, 36? So it should pull out the 4 and the 25. Oh, because I didn't change the code. I still have my or here. And, not or. They're either, I'm sorry, it's and. Not either. It's not an either or. It's the rows of x, which values in column 3 of x. So it's these rows of x which satisfy the condition that they have to be greater than 0 and they have to be less than or equal to 36. And there's only 2 such values in x, third column, that satisfy that condition, which are these 2. So now if I run this, I should get 4 and 25. So you see how find function works with the or and the and. Now find function in Matlab is it ran instantly in our little examples because we have little tiny data sets that we're using the find function on, right? A little tiny data set we're finding stuff in. But if we have a big array, a bunch of data, imagine an array of data which has 6 columns, 6 variables, and 2 million rows, like daily stock returns for a set of companies over a set of years. So we're talking about a lot of data. And you're using the find function. The find function is slower in Matlab than doing logical indexing. So when at all possible, you want to do logical indexing. So I'm going to show you what logical indexing is next. Let's try this same exercise. This last one, where we were trying to find the values in the third column of x that were both greater than 0 but less than or equal to 36. But I don't want to use the find function to do it. I want a logical index. So look, before we do that, let's go down here. I'm going to put CLC just to show you. So x, all rows, column 3, so that's column 3 of x, greater than 0, and x, all rows, column 3, less than or equal to 36. That's logical indexing. So what that'll give is it'll give a logical vector, a logical array, which will be the size of the array will be whatever the size of x is in the column direction, because we're checking in the column. If we were checking in the rows, then the size of this logical array would be the size of x in the rows direction. And I should have set this equal to something. So let me start over. So I'll just call it, I don't know, L. L equals, so x, all rows, column 3, greater than 0, and x, all rows, column 3, less than or equal to 36. And I'll let L equal that. Well, L is a logical vector. And it looks in the column 3 of x, and it asks the question, is this element in column 3, does it satisfy this condition? Is it both greater than 0 and less than or equal to 36? If yes, then it gives a 1. It puts a 1 here. If no, it puts a 0. And then once we've logical indexed, all we have to do is do x of, well, I didn't do this right. So L equals x, all rows, column. I did it right. I was just being sloppy. Greater than 0 and x less than or equal to 36. So that's what L will equal. That's L. And then all I have to do is then just x row, which rows? The rows in L. And it only takes those rows in L that have 1, because L is a logical array. So it only grabs those first 2 rows. And it spits out the 4 and the 25. That's a much faster way of doing things than find. Find does the same thing, but this is called logical indexing. You just make a logical statement like this and set the logical statement equal to some variable name. And then you can use that variable name to pull out what you want. Because this is now a logical array, not a double array, a logical array. And only the places in the logical array which are set equal to 1 will be pulled out whenever you do this. So it's these rows. Which rows? Not row 1, 1, 0, 0, because this is a logical array. So with find, it would actually say row 1, row 2, and you would pull out those rows of x. But with the logical array, it's just a logical vector. It's a Boolean, right? It's a Boolean, either 1 or 0. And it only pulls out those rows of x which correspond to those rows in L which are equal to 1, which be row 1 and 2 here. It's a faster way of doing it. So putting it all together, if you want to do it all in one fell swoop, you would just say grab x, which rows? Those rows which satisfy this condition, where in column 3 greater than 0 and less than or equal to 36. So those rows that satisfy that logical condition, and then column 3, it'll just be that 4 and the 25. That's a faster way of doing it than the find function. But I showed you both ways, find and logical indexing, because find is useful in some instances where logical indexing doesn't work. But usually logical indexing will be faster than find. All right, I think that's a good first little introduction to Matlab. There's a lot of stuff I had in this video, and I went a little fast. And so I think that's where I'm going to end this, and we'll move on to the next video. And the next video will still be basic, but I will probably start to get into actual data work, where we'll have some data sets. I'll show you how to bring data into Matlab from a CSV file or an Excel file or something like that, and how to start to do some data analytics on that. So I hope you enjoyed this, and I will see you on the next one.